Okay, so density. Getting the definition of density. I said to you before that to get a definition, the first place we go is the formula sheet. Okay, and Andrew's already told us we've got the formula sheet, and the formula is what, Anna? Sorry, give it again.
The wee thingy.
The wee thingy?
What's it called?
I don't know.
The P.
Rho.
Yeah.
So it's a P, it's a wee flicky P like that. So a rho equals what?
M over V.
M over V. Now what's the next step in getting our definition? Well, be careful, when I do this, it's M over large V, not M over small v. Because P equals mv, that's momentum. And that's a small v. Okay, this one's a small v, this one should be a large v for volume. Now, so what's the next stage in getting our definition of density? How do we then take that one step further? James, what do we do now? I gave you a little step by step how to do a definition a while ago. What's the next thing we would do? James is currently looking in his jotter. Still looking in his jotter. Still looking in his jotter. A definition, James, definition is made up of words, not formula symbols. So what, sorry?
Write it again.
Write them again in words, okay? So, write it again in words. Density equals mass over volume. Right, what's next? What else can we do to get a definition out of this? What else can we do to get a definition out of this? Carson?
Get the units. The units for it.
Right, so mass is in kilograms.
Yeah, and volumes and.
So mass is in kilograms. Volume is in meters cubed. Right, what else? What else do we need to do then? What's the next stage in trying to get our definition? A definition is a sentence. Density is something, and that's a sentence, that's a definition. So what do we do now? David?
Write out completely.
No, we can't write it out yet. So how are we going to write this out completely? David, suggest how we're going to write this out completely. Density equals mass, what? Per. Where did you get per from? The line. So we replace the line with the word per. So this little line in here is per. Now, the other thing is we've got to kind of think about how we're going to word this bottom part here. Carson suggested we put the units in. For this one, we don't really need units. It's not a definition that you really have to put units in. But you've got mass per volume. You can't just say mass per volume. It's got to be mass per something volume to make it make sense. Jay? Per unit volume. Or mass per meter cubed. But it's mass per unit volume, and that unit volume has to be meter cubed. So we put in unit volume in the bottom. So the definition would be density equals mass per unit volume. Density equals mass per unit volume. Now if it's density equals mass per unit volume, that also leads us on to what are the units for density. Remember, it's mass per unit volume. Now if I put it in terms of the symbols again, rho equals m over v. Replace it with the units, equals kilograms all over meters cubed. Now, because if you should ever, when you're doing maths, have you done negative indices before?
Yep.
This is a negative index of 3 in the bottom, that goes up to the top. So that then equals kg m to negative 3. Because that made the 3m, the m to the power 3 moves up to the top, and that becomes your units. Kilograms, meters cubed, per meters cubed. So that's your units for density. kg m to negative 3. So this has now got our definition and got our units for what density is. Okay, so how much mass per unit volume is the density? The more dense a substance is, the more mass it has in the same volume. Lead has a lot of mass in the same volume as, say, polystyrene. But polystyrene is a lot less dense than lead, okay, because it's the actual mass it has per unit volume. Okay,